Statistics 3, population proportion. Type 2, finding the margin of error. So we have 3 examples here on this. So I'm going to mark them as example 1, example 2, and example 3. So in the first one here, we're asked to express the following confidence interval in the form of the sample population proportion plus or minus the margin of error, and we're given the 95% confidence interval. So therefore we have to remember that it's our sample population proportion minus our error, and then that's less than or equal to our population proportion. So I just noticed there shouldn't be a little hat on that. So if we get rid of that in your example, so the true population is lying between the interval of 0.33 and 0.555. So therefore, if we want to find the margin of error, all we have to do is get the difference between the two and half it. Okay, so it's half the difference. So therefore, if I look here, we have half of the difference would be 0.555 minus 0.333. And therefore our margin of error is going to be 0.111. So therefore, if we're writing it in the form of p hat plus or minus our margin of error, well, that's going to be, so of course, to separate it out, we know that it's our sample population proportion minus our margin of error is less than the true population proportion, which is less than the sample population proportion plus the margin of error. So therefore, if the left is equal to 0.333, well, if I add on 0.333 and 0.111, I get 0.444. So therefore, the sample population proportion must be 0.44 plus or minus the margin of error, which is 0.111. Okay, so then example 2, I'll go on to the next page. So for example 2, we have a sample is used to estimate a population proportion P. Find the margin of error that corresponds to the statistics and the confidence level. So we're looking again for our margin of error. And this time we're given n and we're given x, and we are clearly told that it is a 95% confidence interval. So why does it matter whether they tell us that or not? Well, of course, that affects our critical value, and therefore our margin of error will be our critical value times the square root of the sample population proportion times 1 minus sample population proportion over n. In other words, our standard error of the proportion. So let's set that up. So we're told n is equal to 500, x is equal to 150. Therefore, our sample population proportion is x over n. So therefore, that's 150 over 500. And that simplifies down nicely to 0.3. So therefore, if we want our margin of error, well, that's going to be our critical value, which is often referred to as z. So plus or minus the critical value times the standard error of the population proportion. So that is on page 34 of our maths tables. But of course, this bit is not. We need to know that off by heart. So z is equal to our critical value. And of course, z equals 1.96 for our 95% confidence interval. So we can only use this number if we're clearly told in the question that it's a 95% confidence interval. Okay, and again, because we don't know our true population proportion in this question, we only know our sample population proportion, we adjust our formula to p hat. So if we're setting up our margin of error then, it's going to be plus or minus our critical value, 1.96 times, and then it's our 0.3 times 1 minus 0.3 all over our sample size, which is 500. And therefore our margin of error is going to be 0.040168. And that's all it asks for here in this case. It just says find the margin of error. So we don't need to actually set up our confidence interval, just the margin of error. Okay, so in part 3 then, it says RTE claim that 60% of all viewers watch The Late Late Show every Friday night. An independent survey was carried out on 400 randomly selected viewers to see if the claim were true. The result of the survey was that 180 were watching The Late Late Show. Calculate the standard error. Now what you'll see is missing here in this question is that we're not told that it's a 95% confidence interval like in example 2. So therefore we would, in this case, only be working out the standard error. So n is 400, our sample size. And if we go back to the question, you can see that they were saying that 400 randomly selected viewers and then 800 claimed that they were watching The Late Late Show. So we would have 180, I should say, sorry. So therefore we have our sample population proportion is x over n. So that is going to be 180 over 400. And again, that simplifies nicely down to 0.45. So because we're not told 95% confidence interval, then it's plus or minus our standard error. And again, we don't know our true population proportion, so we use our sample population proportion over n, and that would be times our critical value. So again, we'd literally just be looking at whatever the critical value is, whatever the confidence interval is, but we don't know. So in this case, it's just going to be plus or minus our sample population proportion, which is 0.45, 1 minus 0.45, over our sample size, which is 400. So therefore our margin of error in this case would be plus or minus 0.02487. And then that would be adjusted based on the critical values by multiplying it by the critical value. But for the leave insert, you will always be given the 95% confidence interval really for these margin of errors. Okay.